Next, we will talk about some of the recent conclusions from the Intergovernmental Panel on Climate Change report that was put out near the end of 2021. So in 2021, Working Group 1, which is just one of a number of working groups within the Intergovernmental Panel on Climate Change, published an updated report, and this report summarized evidence that supported global climate change and the causes of global climate change. This report was compiled by 234 different authors from 65 different countries. They examined and synthesized more than 14,000 science research articles into one report. And this report, there's a long version of it, and then there's a summary for policymakers, which is what I am using to pull these images and graphs and charts. The IPCC consists of multiple working groups and has included work by thousands of scientists from more than 100 countries across the globe. So the report from the IPCC begins by just showing how much the average global surface temperature has increased since about 1850, and even going back much longer ago than that. So in the image on the right, or the graph on the right, scientists reconstructed the temperatures from the last 100,000 years using ice cores, ocean sediment cores, and other climate proxy data like speleothems or cave rocks, less sediments, and many other different proxy tools. And so from these proxy tools, they were able to reconstruct the approximate temperature on Earth during that time. And you can see, like, there was a dip at one point. There was an ice age. We know there was different things that happened. But you can also see that the warming that we see in the last 100 years is unprecedented. We haven't seen that kind of sharp increase in temperature at such a rate in the last 100,000 years. On the right, we see the temperature that's been measured. So this is human measurement of temperature around the globe since 1850. And you can see the temperature was fairly steady, and then it began to creep up in the mid to early 1900s as the industrial age started to get going, and then it really started to increase after about 1950. So on this chart, you can see the chart on the right, the black line is the actual observed temperature, measured temperature. The brown line is the simulated. If you use climate models to simulate the temperature, then they are simulating this same temperature profile by including both natural causes and human factors in the climate model. If they remove human causes and factors, then they get the blue line on the bottom, so that the simulations say that Earth's temperature would have remained fairly steady if we just factor in solar radiation and volcanic influences. But when you start to factor in human influence, especially the emission of greenhouse gases, then we're able to mirror the observed temperature increase. So this report and summary for policymakers, it has many different maps and charts that look like this one. So I'm going to start by breaking down what this chart is, and then we'll talk about the data and what it's telling us. So this chart's really a global map. Each hexagon on the map represents a different region on the globe, and the hexagon is located in its approximate location on the globe. So on the left of the map or chart, we see the Americas. So the North America regions are up on the top left, then we have Central America underneath, and South America on the bottom left. As we move from left to right, we go from North America over to Europe, and as we continue over, we get to Asia. And then if you head south from Europe, you'll see Africa, and as you head south and east from Asia, then you see Australasia and Pacific Island nations. So what is this chart really telling us? This particular chart is examining the occurrence of extreme heat events across the world, and all of the regions, all of the pink hexagons are regions of the world that have seen a significant increase in extreme heat events since the 1950s. So you can see that most but not all regions of the world are seeing an increase in extreme heat events. There are a few areas that are really not seeing a huge increase in extreme heat events, but they are experiencing other climate influences, such possibly as flooding or other types of events. Regions that have 3 dots, so areas like Northwestern North America, NWN on the top left, these 3 dots are telling us that there is high confidence that human contribution is causing this increase in extreme heat events. Regions that have just 2 dots have only medium confidence, and then areas with 1 dot, either they're not seeing an increase in extreme heat events, or they have limited evidence so far because there's not as much data that's been collected on those regions. On this chart or map, we have the same regions that we saw in the previous slide. However, it is showing which regions are experiencing increased drought. Drought is often caused by a combination of factors, including less precipitation and higher temperatures. And when you have higher temperatures, this leads to increased water evaporation from soil and plant surfaces on the ground, which can lead to agricultural or ecological drought. So sometimes drought is occurring just because there's an increase in temperature. So even if precipitation stays the same, if temperature increases, you're going to have increased evaporation, and that can cause the areas to dry out. This chart or map is telling us that the regions in yellow have seen an increase in agricultural and ecological drought, and that includes areas like Western North America, so that area is in yellow. Also Northeastern South America, much of the southern and western regions of Africa, the Middle East, India, and parts of Asia are all experiencing more drought in recent years. So while some regions have experienced more drought, other regions are seeing increases in precipitation that can lead to dangerous flooding. So how can climate change cause both drought and flooding, you might wonder? Well, a warmer atmosphere holds on to more water. So areas that experience high evaporation, places like deserts, even though more water, because it's warming up, more water can evaporate from the surface, and this can lead to enhanced drought. And then in more humid regions, the air is moist and it's holding on to more water. So when storms do occur, more precipitation comes out of these storms, which can lead to more flooding. So much of Asia, Europe, Southern Africa, and the eastern United States have seen an increase in heavy precipitation events since the 1950s. You also may notice that some regions on this map are green, but they also were yellow on the previous map, meaning that they're experiencing more drought, but they also are seeing more heavy precipitation events. So these regions may experience large seasonal changes in precipitation, such that their dry seasons are becoming drier, but then their wet seasons are also becoming wetter, which leads to both drought and flooding events.